Hello everyone, welcome back to Algorithm with Chelsea. Today we are learning a new kind of loop in Python, the while loop. A while loop is great when you do not know exactly how many times you need to repeat. Let's begin. A while loop repeats a block of code as long as a condition stays true. Now look at the syntax. It says, while, condition, then a colon. The code inside must be indented, usually 4 spaces. Important rules. The condition is checked before each loop. So if the condition becomes false, the loop stops right away. Now let's talk about a big danger, an infinite loop. An infinite loop means the loop never stops. Look at the code. The first line sets I to 10. The condition says, while I is greater than 0. Inside the loop, we print I. But notice, I never changes. So I stays 10 forever, and I, greater than 0, stays true forever. That means it will print 10 again and again and again, forever. Remember this. If the loop variable doesn't change, the condition will never become false. The while loop will run forever. Make sure your while loop will eventually stop. You must avoid infinite loops in your code. Now let's do a correct while loop. The goal is to count down. Print 5, 4, 3, 2, 1. Look at the Python code. We start with n equals 5. The condition says, while n is greater than or equal to 1. Inside the loop, we print n. Finally, we do n equals n minus 1. This line is the key. Because n gets smaller each time, it will eventually become 0. When n becomes 0, the condition is false, and the loop stops. Here is the output. It prints 5, 4, 3, 2, 1. Exactly what we wanted. Now we solve the counting digits problem. We have studied it in a previous lecture. Goal. Given a positive integer n, how many digits does it have? Obviously, n equal to 2026 has 4 digits. Here is the idea. We keep removing the last digit until the number becomes 0. If the input n is 2026, it will become 200, 2, then 20, then 2, and finally 0. To remove the last digit, we use integer division by 10. We count how many times we removed a digit. That count is the number of digits. When n becomes 0, we stop the while loop and output the count. Here is the Python code. Let's understand the code line by line. The input n equals 2026. We create count equals 0. Count will track how many digits we removed. Then the while loop. The loop condition is, while n is greater than 0. That means keep looping as long as there is still at least 1 digit left. Inside the loop, first we do count equals count plus 1. It measures how many times the while loop repeats. Next we do n equals n divided by 10. That removes the last digit. When n finally becomes 0, the loop stops. Finally, we print count. The output is 4. That means the input n has 4 digits. Now it's your turn. Look at the code. The input n equals 5. We use the same program to count digits. What will be printed? Pause the video and solve the problem. Let's check. If n is 5, then n integer divided by 10 becomes 0 in one step. So the loop runs exactly 1 time. That makes count equal to 1. So the output is 1. Now we do another classic digit problem, sum of digits. Goal. Given a positive integer, such as n equal to 1234, compute 1 plus 2 plus 3 plus 4. The idea is similar to counting digits, but we add one more tool. We use an accumulator called total, starting at 0. Each time, get the last digit in the same way as before. Let x be n modulo 10. Then accumulate x into total. So total will be the sum of digits. Remove the last digit using integer division by 10. Also the same as before. Stop when n becomes 0. Let's read the Python code. The input n equals 1,234. We initialize total to 0. That's our accumulator. Then the while loop. The condition says, while n is greater than 0. Inside the loop, we get the last digit by n modulo 10. Denote the last digit by x. Then we do total equals total plus x. That adds the last digit into our running total. Then we change n to n integer divided by 10. This removes the last digit from n. When n becomes 0, we stop the while loop and then print total. The output is 10. It is the sum of the digits 1, 2, 3, 4. The next topic is finding Fibonacci numbers. Fibonacci numbers are a sequence that starts with 1, 1, 2, 3, 5, 8, 13, and so on. Each number is the sum of the two numbers right before it. For example, 13 is the sum of 5 and 8. Here is the goal. We want to build a list of Fibonacci numbers that are less than or equal to 100. So we keep generating new Fibonacci numbers, and we stop before we go over 100. Here is the idea. We use a list called fib to store Fibonacci numbers. The list starts with the first two items, 1 and 1. To get the next Fibonacci number, we add the last two numbers. In Python list, negative indices mean counting from the back. So the next number is second to last plus last. We keep adding new numbers to the fib list. Stop when the next number would be greater than 100. Here is the Python code. We start fib as the list with 1 and 1. Then the while loop. The next Fibonacci number is the sum of the last two items. The condition checks if the next Fibonacci number is less than or equal to 100. Inside the loop, we do fib.append, and we append that same sum. It means add a new item to the end of the list. When the next number would be too big, the loop stops. In the end, we print the list. Here is the output list. It ends at 89 because the next Fibonacci number would be 144, which is bigger than 100. This list contains all Fibonacci numbers up to 100. The last topic of this lecture is the Collatz game. Here are the rules. We start with a positive integer, such as n equals 7. If n is even, set n to n integer divided by 2. If n is odd, set n to 3 times n plus 1. We keep going until n becomes 1. Goal: output all the n produced by the process as a list. Let's turn the idea into Python code. The input is n equal to 7. We make a list called result, and we put n into the list as the first item. Then the while loop. The loop condition says, while n is not equal to 1. So the loop keeps going until n becomes 1. Inside, we check if n modulo 2 equals 0. That means n is even. If it is even, we change n to n integer divided by 2. Otherwise, it is odd. We change n to 3 times n plus 1. After we update n, we append n into result. We are collecting every step into the list. At the end, we print result. Here is the output list for n starting at 7. It shows every number the game produces, and it finally ends at 1. Our program successfully simulated the Collatz game and saved all steps into a list. Let's summarize. A while loop repeats a block of code as long as a condition stays true. The condition is checked before each loop. In a while loop, something must change inside so it can stop. Today we studied 4 examples: digit count, sum of digits, Fibonacci numbers up to 100, and the Collatz game. Finally, compare for loop against while loop. Use a for loop when you know how many times. Use a while loop when you don't know how many repeats you'll need. This concludes our lecture. Thank you for watching. Please subscribe to Algorithm with Chelsea so you won't miss future updates.